Hello, everybody. A lot of people are today joining with us for this webinar about surveying modules. So I'm David Vincent from Applitop, and today will be with me for the demonstration my colleague Antonio Pardo, which is a surveying engineer, a geodetic and surveying engineer, which will make the live demonstration of the surveying modules. And please note that this webinar is recorded and you can find it into the video library on our web page. You have also the possibility to do all your questions on the command and the live demonstration. If you need some complementary information, my general manager, which is also with us today, will try to reply to all your questions in the same time. And if we don't have the specific reply to your need, we will send you a personalized email. Okay, let's start everything. Let's start this webinar. So, for those who doesn't know who we are, Applitop is a Spanish company based in the south of Spain, in Malaga, and we are a company specialized in the development of applications for surveying and civil engineering. We have got a great expansion around the world with more or less a little bit less than 80,000 users licensed worldwide, and we work exclusively through previously selected distributors. The success is because, as you will see, our software are very easy to use, but also they are a really competitive price, which give a really great investment because due to the productivity of the software, making your needs and your results, it has given us a great success. One of the other points that I told you is we have always distributors who are able to give a first local support, but also we have a great after sales department which can help you in the eventually specific needs for your market or your detection of some installation or this kind of things. We offer different kind of training from basic to advanced, and we have a channel, YouTube channel, where you can put subtitle in English or in different languages to perform better knowledge on our software. Our quality is about, we have different agreements which says that we have good quality, like ISO 9001 or innovative SMEs. We have we work so much for public and private project, and about public project, we have relevant project like Roadbeam, Autobeam, or Pandora that I invite you to discover into our webpage. Some universities and association at international level, we work with the LandXML, which is a generic format of exchange between a lot of software and instruments. Applitop is very involved into the building smart, and we are certainly a pioneer in surveying field about exporting superficies or axes in IFC formats. What about our software? What are they able to do? So we can manage different projects of urbanization, roads, quarries. We have tunnels and power and several projects of surveying. One thing that it is really important is our development partner is so much on Android, Apple, S3, Intel, and Microsoft, which when we need a CAD, and in the case, it is the case for today, when we need a CAD, we work so much on AutoCAD, on BricsCAD, and on ZVSoft, on ZVCAD. We have brand agreements. This company let us their last instrument in order we make it compatible with their instruments and able to use directly their own format, or in order to don't pass, for example, by LandXML or other generic format. ApplyTop is 4 families software: surveying project that we will see today, one module specifically, tunnel project, field for the field works with your GNSS, so much on Windows and Android, and photogrammetry. ApplyTop actually is working on new point clouds management software, augmented reality, drone, and BIM for infrastructure. Our national reference are the biggest Spanish contractors that working around the world, like SACIR or Acciona. We have also great implementation in different universities. Some international reference, we have a lot of great projects, like the biggest highway from the east part of the American continent, which will cross all the America from south to north on the east part, with projects in Canada, Ecuador, Peru. Actually, we are working in Colombia and Panama. The underground of New York, or the big project of Riyadh, with a project of underground and part of road and this kind of things. So very relevant project that can give credentiality to our software. Okay, just give me 1 second. Okay. So before to let hands to my colleague Antonio, okay, I would like to make you a quick resume about TcpMDT. TcpMDT has 2 versions, a professional version and a standard version. On each one, on the standard or so much on the professional, you can add the image module, the surveying module, or the point cloud modules. You can install point cloud on standard or on professional. The module of surveying in yellow that we will see today can be installed so much on the standard than the professional. What are the main features of each version and each modules? The standard version is to work with point management, making your DTM, contour lines, and to get your profile and cross section. When we want something more sophisticated in order to prepare earthworks or design a road project, you need the professional versions. The surveying modules is to process total station measurement, make transverse and networks, coordinate transformation, and geodetic calculator. You will have all the demonstration today. The image module is to work with orthophoto or download from web map services pictures with location in order to apply into your DTM and get real 3D reports. Point clouds is to work with laser scanner or LiDAR and to manage your point cloud into a CAD, which is a great issue. The system requirement for MDT is from Windows up to 10 and CAD compatible, as I told you before, is already available on AutoCAD 21, okay, in 32 and 64 bits, with BrizCAD V20 and ZVCAD also V20. And thank you for your time. Now I will let hands to my colleague, Antonio. Antonio?
Hello, David. Thank you, everybody. Hello, David. Thank you, everybody. My colleague said, today we are going to look one specific module from the TcpMDT, the surveying module that nowadays, sorry, nowadays is very useful to any surveyor like me. I am a survey engineer and cartography and geodetic engineer. We can find the different way to calculate any kind of way to calculate any data from from total station, theodolite, or something like that. Okay, this module is divided in 2 parts mainly: the surveying and coordinate system. Surveying is focused in calculate from device like a total station or theodolite, and we can use or we can calculate traverses, a network, or even resection, reverse bisection, direct intersection, reverse intersection, trigonometric leveling, etc., etc. Or maybe we can calculate, we can make any kind of transformation from the global system coordinate or local system coordinate and convert or transform even drawing or even files or something like that. I said before, is a useful tools to anyone like me to calculate anything in our work daily. So today I'm going to show one basic example. Okay, this is one example, one work that I did 12 years ago. Okay, so in the middle of the city center. Okay, where where there was a lot of street with a big building, and in narrow street or bigger streets. And in this case, we have to use a total station to carry out our work. So in this work, I survey this area. Okay, I'm going to show, for example, the detail of this work. Okay, we will survey everything. Okay, the furniture, urban furniture, and the strip, the pavement, and everything here. Okay, so with these tools, I calculate the difference along different traverses along the work. Okay, this work is around 40 hectares of streets, so it's very bigger work. Now I'm going to cut one part of this work to show how work with these useful tools. Okay, so I'm going to use a new drawing. Okay, the first of all, I'm going to import the data. In this case, I'm going to use surveying import data. Okay, import. Now show up this window where we can select different formats from different manufacturer. In this case, we are going to use amplitude format. Is one format that we can find in text AXT file. Okay, so I'm going to use that, select that. We can use two LXMLs, Leica, Tremble, etc. Okay, now I'm going to select the file. This is the original data. Okay, I'm going to have a look this file because this is a AXT file by text file. I'm going to open, and now there is the data of the data that we measure from the field. Okay, so the first part, we find the coordinate, the origin coordinate, where we are going to begin to calculate. Okay, the second part, it's all the measure or all the observation that we carry out in the field. Okay, for example, this is the station where we are measured. There the station that we measure, or maybe the point that we observe in the field. Okay, in this stage, we can find the horizontal and vertical reading from the total station. Very important things, the horizontal distance is, I'm going to remark that this format use the horizontal distance and not use the slope distance. It's very important things to remark. Here there is the height, the pole height or the road height, and the different code that we are going to use to draw automatically each entity. Okay, and then we repeat the same format for each station. Okay, in this case the station number 5. Okay, all the readings, and the station number 12, all the reading, the station and the point that we read in the field, and etc. to repeat the same format. Okay, so I'm going to I'm going to click on OK, and I'm going to load. Okay. Okay, and now the application it's going to save all the calculation and all the operation that we made in that file, Traverses Madrid left. This station is very important because we save here all the calculation. Okay, save. We are going to replace another one. We can make a review, a quick review here, the horizontal reading, the vertical reading, the horizontal distance that we are going to use. Okay. Here is the mainly window to calculate our works. Okay. First of all, I'm going to explain how work this window because maybe it seems some difficult because we can do everything here, but it's very easy to work with this. Okay, when you understand, obviously. The first part, we can list the station that we are going to use, that where we are going to make any observation. Okay, for example, there are the station number 6, the station number 3. They are the first station that we know the coordinate. Okay, they are the coordinate that I said before in the layer format, and then in this square we can check the observed stations. Okay, for example, from the station number 6 we read the station number 3, the station number 4, and the station number 5. And even it said if you made a simple reading or double ribbon, the reciprocal reading. Okay, and then we can show in this schedule the instrument setup all the configuration for the station origin, the origin station. Okay, in this case we can check the instrument height and the horizontal correction to calculate the bearing or to calculate the azimuth. Okay, we can setting up all the station at the same time when we need to change something. Okay, and we are going to see to check how change all the horizontal coordinate correction for each station. Okay. The final result we can find here in the coordinate because at the end of the work we are going to calculate some coordinates. So in each stage we calculate different coordinates from each station depending on the way we use. So we can find each coordinate from each station or depend on the way that we are going to use. Okay. At the end we can check a simple or a small resume of the difference between the calculated coordinates. Okay, in this square we can select the different way that we are going to use to calculate something. For example, we can calculate inverse bisection, resection, or trigonometric leveling, depending on the data that we have in the window, in the data that we have to allow us to calculate or not. Okay. At the end, we can draw everything, draw the station or draw the final points, etc. Okay. Well, let's go to how to calculate with this window. First of all, we are going to configure it to set up the parameter to calculate our traverses. And this part, we are going to define this coordinate reference system. For example, we are going to use this reference coordinate set, ED50, and in UTM Zone 30 North, Zone 30 North, and we are going to use this correction, the sphericity and refraction, the reduction of to ellipsoid, and we are going to use combined scale factor, okay, to the projection. Okay, we can configure, for example, the tolerance of the error to in order to the application. Sorry, in order to application advise us if there's an error or there there are some error or over the tolerance, something. Okay. And now we are going to check the first coordinate. For example, in coordinate, click on coordinate, list the current coordinate that we are going to use. Okay, in this case, there are the station number 6 and 3, and they are in flat projection. So we are going to change the factor of the projection. So select all and going to change to a projected factor. Okay, to calculate the different distance along the calcul. Okay. Now, due to we don't know what is the schedule of the traverses, I'm going to calculate quickly by automatic way to show how to do it. Okay, I know that the origin of the traverses is in the station number 6. Okay, I'm going to click on origin. Okay, these stations are fixed. When we compensate the traverses, we don't move this coordinate. Okay, because they are the origin of the traverses. Okay, and if you realize, when I activate origin, this button it's activate too. For example, okay, you can check the difference. Okay, if I click in origin, it's activated origin automatic, because the application detected that it's possible to calculate now. So we are going to click on automatic to calculate the traverse everything automatically. So only to say that the application it's going to make any kind of calcul with the data that it's fine in the data, no? Calculate everything, and then it show us the one table of results what it's calculate that it made. Okay, for example, here appears the different residual, and it's remark what it highlight by asterisk the result that it's are over the tolerance that we set in configuration window. Okay, we are going to accept. Okay, it's possible to review some reading here in this station if we consider it are very high. Okay, but in this case we are going to accept. If you notice, only to notice that in each station now we have a different result for each station. Okay, so these results are calculated by automatically by our application. So now it's calculate all the traverses. It's very easy. So I don't recommend this way to do step by step, station by station, to avoid some error or some systematic error or alternative error. Okay. So we are going to draw the station to understand the traverses. Okay, draw a station. Okay, and here all the station and the traverses that we or the network that we carry out. So how we can do it manually? I prefer to do manually. For example, only to check the station number 6, okay, is this, and the station number 3 is this, is the first coordinate to calculate the orient. So we are going to change the horizontal correction to calculate manually. For example, instead setup, instrument setup, I'm going to edit the first correction. I'm going to delete the horizontal correction to calculate again. Okay, manually. Okay. 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 In this case, we don't have the correction, horizontal correction in the station number 6. Okay. So we are going to calculate manually. if you check, this button is activated because the software detected if it's possible to calculate, because we have two coordinates in the station number 3 and the station number 6, like before, and we can calculate the orientation. Okay, so we select the station number, the origin of the station, the number 6, and the observed station number 3, and we click on orient to calculate the horizontal correction. Orient, and here is the same horizontal correction. Okay, this is to calculate the azimuth for each observed reading. Okay, so then we need to move along the traverse for each station. For example, we are going to calculate the coordinate to the station number 5. For example, we select the station number 6 and we select the station number 5. Notice that we have D. It means that we have a direct measure and the reciprocal measure. Okay. Okay, we are going to click on manual. Okay, and appear the the information window where it's show the forward distance and the height forward and the backwards distance and the height difference. Okay, add the difference between them. Okay, in this case we can find 2 centimeters between the forward and backward direction. Okay, and the horizontal correction in this case is 0. Okay, pues we accept. Okay, and automatically the software go to the station number 5 to go to calculate with the station number 12. Okay, in this case number 12 is the next. We can check manual and we click on OK to get the same. Okay, and repeat this step for each station by station, for each way, for everything along all the traverses. It's very easy to calculate manually. I recommend to use manually than automatic. Okay, so automatic fast way, and if there isn't any error, there isn't any problem. Okay, is recommended too. Okay, so I said before that we can make some different calcul. Okay, so there are some weights. For in this case, we are going to use, for example, we are going to select the station number 7. Okay, station number 7. If you realize, is activate the different ways of calculating. For example, reception. Okay, if I select, for example, the 8, it's not allowed, but when I select 7, is activated automatically because the software detected is possible to calculate one reception with the data that we have now. Okay, so reception, click on reception, appears the inverse intersection that we can make here. In this window, we can select two. We also select a different way. For example, we can select only use the angle, only use the distance, or to calculate in 2D or 3D, or maybe we can play with different stations. We are going to use, for example, the 4 and 16, and I'm going to avoid the 14 for different try. We can try different possibility. Okay, and here in this square we can find the final result for each calcul. Okay, if we change the difference selection, the result is different. Okay, here appears the error ellipse for each calcul, and we select different situation. Okay, we are going to accept this calcul, and here, as you can find, we can find another result, another coordinate to the station number 7 for the reception way. Okay, we have different result for this station. If we calculate from the station number 5 or the station number 14 or the station number 4, or by intersection. Okay, that is very interesting this way to calculate everything. Okay, I said before, we can find here the difference between different results. In this case, it appears distance error the 5.6 centimeter. Now everything is calculated. Now it's rest to compensate, for example, the coordinates. Okay, pues we are going to use only to say that the coordinate that the application is going to use is the coordinate that is selected in this window, in this part. Okay, for example, in the station number 6, we are going to use the direct assignment, or the station number 5 is going to use the coordinate from the station 6. Okay, or maybe in the station number 7, okay, we are going to use the inverse intersection, no? Okay, is one solution, the primary solution to use to compensate the traverses. Okay, we are going to compensate these traverses, okay, or this network before. Traverses, click on traverses, and now to compensate the traverses, we need to arrange the traverses, okay, to define the traverses. Well, we are going to select graphically each station that composite each traverses, okay. In this case, the different station, I'm going to click on different station that composite the traverses, okay, and here is. I'm going to say to the software that it's a closed traverse, okay, it's very important. And for me, in my case, I like to save this configuration, okay. I'm going to export this configuration. I'm going to save in this file, the file .pol, save, okay. Because I like to save that because sometimes we need to repeat a lot of time the compensation to check the difference between different weights. Okay, so in this case, I'm going to compensate the traverses, and here is the window of compensation. Okay, overall, we need to check the different parameter. For example, the distance error at the end of the traverses, in this case is 6.6 centimeter, and the length of the traverses, or the error, the angular error that we can find, or the coordinate error that we can find in the traverses. Okay, it shows the primary coordinate for each station and the horizontal correction that you use to the compensation. Okay, we can select the way of calculation, for example, the least square, or maybe proportional distance, or proportional increments, Crandall, etc. At even, we can fit in planimetric or altimetric, or both of them ways. So we are going to compensate by this way. This error, we are going to compensate only to click on compensate. The software calculate by this way and show us the different residual that it's fine in the calcul. Okay, but the software advise us about its passing the test square chi, okay, statistical test, to allow us to know it's a good way to compensation. The compensation is successful. Okay, after this, we can print the resume of the calcul to include all the observation, all the coordinate compensate coordinate, and everything, to maybe to create a report or something like that. Okay, it's very useful to use that. Okay, it's everything. Okay, I'm going to accept. I'm going to click on OK. Okay, click on OK too. At the end, we can check we can find the final coordinate the compensate coordinate for these traverses, and everything is calculated too. Okay, compensate. Okay, is a very useful and easy way. The same thing if we want to compensate a network. Okay, we can click on network. We can select, in this case, we can select graphically each station that we want to include, or maybe we can use an automatic way. For example, automatic, okay, and select all the station and all the observation that we can use to calculate, okay. And we can use compensate is the same like the last one, okay. Okay. Now we can check the final coordinate that we are use and the scale of the projection that we use, okay, for each station, okay. Okay, and now we are going to draw the final objective, no, to draw the points, okay. So we are going to draw the points. Here is going calculating. Now the application is calculating each coordinate for each point, observed point, and to show the list for each point by point. Okay, it lasts some minutes because there are some different calculus. Okay, we need to wait some minutes, and then we are going to draw automatically by code. We are going to represent it we are going to drawing all the entity, linear entity or punctual entity by block using the code database. Here is the finish point of drawing. Okay, we are going to draw all the point. Okay, and now we are going to say to the application how we are going to draw. We are going to draw using the codes. We can select the code database here, only to say where is the code database file. In the case, okay, and we are going to use this scale, okay, to define the text height in our drawing. Okay, we are going to click on OK and start to draw all the points along the street in the survey that we carry out in the field. Okay, and here it is. Okay, we can check the draw all the entity, the linear entity, like a building, facade, like a brick line, and everything. Okay, so only when it's ready, everything is calculated. All the calculates are saved in the file let file to if we need to check or to edit something, we load again. Okay, we are going to click on OK to pass to drawing steps. Okay, like I said before, there are the observation, our traverses, okay, and this is our final draw, okay. We are going to list the list point, okay, all the point, and here is the final coordinate, the codes that we used in the measure, and we can show the different attributes. For example, each point is from total station, from the station number 6, with the instrument height, with the reading, and the different height of the pole, or something like that. We can find everything, okay? And now, I said before that all the entity is very useful because all the entity is drawing automatically. For example, we can find here the strip line that we need to rotate directly, okay? Because we need to, sorry, we are select only the strip line, rotate, okay? We need to rotate the strip line to edit the drawing, okay? Only to say that it's possible to avoid that if we use 2 points or 3 points. In the last version of MDT, we include the possibility of use 2 points to locate and scale and rotate each block depending on the position of the point that we are going to use. Okay. For that, I'm going to show the code database. Okay. For example, points, code database. Okay. This is the code database that I use, where I specify or I define each block we are going to use depending of the code. Okay, so we can define the code, the level where we are going to save each point, or classify the point, the type of the point. For example, if we use the point like a punctual or like a linear, like a line, okay, point with only 1 point or 2 point or 3 point. I said, like as I said before, the layer that where I'm going to draw in the drawing, the color, the thickness, or maybe the block or the kind of the linear that I am going to use. Okay, it is possible to edit any configuration, but it's not necessary to do it. Okay, cancel. I'm going to show the difference if you use only 1 point or 2 points. For example, in this case, there are 2 points. I'm going to go to the vision control vision. I'm going to show the code. I'm going to hide the name and the height. Apply. Okay. In this case, the software draw the block using the first point to locate the block and the second one to scale and to rotate the block, okay, and adjust. So if we use 3 points, here is the difference. The first one to locate the block, the second one to rotate the block and to scale the block in the X direction, and the third one is used to calculate the scale in the Y direction. Okay, so if you look, there is fits in the exactly point. Okay, this is the one example, and here is another example, 2 points, and the third one to calculate the Y direction. Okay, in this way, it's very useful because allow us to avoid to rotate each block block by block like this. Okay, because it's very useful to reduce the time of drawing in the office. Okay, it's very useful it's to demand for every hour of service. And now we are going, for example, to edit some entity of the drawing. For example, we are going to in brick line. I'm going to create a displaced parallel because I forget to take the top of the curves. For example, no, I'm going to create this command. I'm going to set only to create a polyline. I'm going to increment 14 centimeter from the asphalt line. Okay. Going to OK, select the asphalt line. OK, I'm going to say the pointing at the direction here, 10 centimeter of the distance here, and there is the 3D parallel to this entity. OK, I'm going to repeat the same for this. OK, pointing at the direction, click on 10 centimeter, and here it is. And now, for example, I'm going to reply. Here is. Sorry, I forget to click on here. And here is the curves, the top of the curves from the asphalt and this brick line. Okay. So it's very easy to use the different tool that MDT offers us to work. Now, with this final works, I am going to create a surface to this work. Okay, so I'm going to use mainly first of all I'm going to use those polyline to use like an island in the middle of the building. Okay, I'm going to copy. Okay, I'm going to change the layer. Okay, I'm going to change the layer, and I'm going to copy in the island layer. Okay, and now I'm going to move again and the original position. Example, here, there is the facade of the building. Okay, and now I'm going to create a surface. MDT, surface, create surface. I'm going to save in this file. Okay, and here we can select what we are going to use to triangulate. We are going to use all the points that are classified by levels depending on the code, okay, on the code database. And we are going to use the brick line. In the code database too, we can select the different polyline that are classified automatically by code, okay. And now we are going to use the island. We're going to select the island that we have already drawn, okay. And now we don't have any boundary, so we are going to use another criterion like this, the 25 meter, to create a triangle. Okay, I'm going to draw in 3D. Okay, and here is the triangulation. Now as you check, the island is not included, and now there are some error here in the boundary because there isn't any boundary defined. Okay, so we are going to edit the surface, the lit line. It's easy like that. Okay, like that. Okay, we can delete the triangle that we don't use. Okay, 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 okay. Okay, I'm editing the surface to calculate the final boundary of the surface. Okay, so it's too easy to calculate that because MDT break line, for example, find boundary, and here is the final boundary. We can repeat we can repeat the create to surface and use that final boundary to triangulate, but in this case it's not necessary. So now we can create a quick profile, for example, to check the work. And here is one profile of this representation. Okay, and we can find the first strip, the second strip. Here is one square. Another strip here is here. Okay, we can find the different curve, or if we have some error or something like that. Okay, we can define or check the different height, etc. Okay, now we are going to create a contour line, for example. Okay, I'm going to select the 10 centimeter for interval, and I'm going to labeling that. Okay, automatic way, and here is, but it's everything. This is our work finished. Okay, it's a easy way to get the cartography or to get the final work, the final result of our work. Okay. Okay, so now we are going to review, or we are going to look the coordinate system to how to work with this. Okay, for example, we can use geodesy. We can define the different datums for depend on the we can define directly, or maybe we can use the EPSG data set to use them depending on the location, no, of the area. Okay, it's very easy to define our datums, or maybe use the data set that I said. Okay, we can define the different format to represent the final result of everything. Okay, this is the configuration of the geodesy parameter. Okay, in the same way, we can convert different drawing or different file. In this case, I'm going to convert our example to another system coordinate. For example, convert drawing, all the drawing. I'm going to define the current system coordinate, the source coordinate reference system. So I'm going to change. This is that I said before, is ED50 UTM 30, and this is the current system coordinate. I'm going to transform or to convert in another system coordinate. Pues I'm going to choose what is this is the last coordinate. Okay, the last coordinate I want to change the draw. Okay, and we can check the original system coordinate and the target coordinate reference system. Okay, I'm going to use to convert everything. Okay, so I'm going to click on OK. All the entity are converted. Okay, and here it's converted here. Okay, to check the conversation, I'm going to draw from the surveying station calculation the station. Okay, I'm going to draw again the different traverses, in the original system, because are defined with the original system coordinate. Okay, so I'm going to draw the station. Okay, and there the original station in the original system coordinate system. Okay, here is and here is. This is the difference between both of them global coordinate. Okay, now we can use the same thing but with local coordinates. Okay, imagine that we use we want to define we get some project from the architect, for example, and normally they define or they drawing in local system coordinate. In this case, I'm going to use, for example, one project to about 1/10 that we are going to install in this area. Okay, in this area we are going to install that tent. Okay, so the architect used this local system coordinate, and we are going to calculate the parameter to our local system, our global system coordinate. So in this case, xref. Okay, I'm going to attach the file. Okay, this is the same file of our project in the global system coordinate, and now I'm going to calculate the difference between both system coordinate. So I'm going to calculate, for example, I'm going to use the middle of the pillar to make a matching between both of system coordinate. So MDT point convert drawing from object. Okay, I'm going to select the option of the block, this block. Okay, now I'm going to create a 1 point for each pillar. Okay, I'm going to use the name of this layer. Okay, I'm going to select the layer, this layer. Okay, okay, and okay, and here is all the points are created from each block. Okay, now I'm going to save all the points in one file. Point, export point. Okay, all the point. Okay, okay. I'm going to set here in this file. Replace. Yes, I'm going to replace. And here is. This is the local system, the local coordinate system. And now I'm going to the global coordinate to calculate the different parameters. For example, MDT8, coordinate system, local system. I'm going to create a new local coordinate transformation. In this case, 2D transformation, and this is the transformation that I'm going to use. Okay, by points. Okay, and here is. Now I'm going to say where is the source file. That is the file that I create right now. Pillar project, open, and that is the list of the point of each pillar. Now we can use a target file, but we don't have it. So we are going to select graphically each one by one. For example, we are going to use the pillar number 1. I'm going to edit. I'm going to select the match graphically. The number 1 is here. Okay, this is the pillar number 1, and here is the pillar number 1. The matching each point. Okay, and now I'm going to repeat, for example, to the last point. Edit. Going to edit, and the 48 pillar is this. Sorry, is this. Okay, and here is here. Okay, and here is the. If we can check that all the parameters. In this case, we don't have any residual. We can check, for example, we are going to use the point number 3. Edit. I'm going to select point number 3. 23, for example, 23 is here. 23 is here. But in this case, I'm not going to use the exactly point. I'm going to make some wrong. Okay. For example, I'm going to click here. This is not the same. Okay. And now appears some residual depending of the bad position of our point 23. Okay, so we are going to don't use this point to calculate, and we are going to save the transformation. Save as transformation local to global. Okay, this is the direction of the transformation. Okay, save. Okay, transformation is created. Okay, and we don't have it. We have it. Okay, and now what we can do with this? If we define something, our architects define something in this file, for example, okay, one circle here, one circle here. Okay, we are going to, for example, here we are going to convert directly the original transform drawing. Okay, we are going to select the transformation. In fact, you realize we have the inverse transform rate. I said I calculate before, and we are going to select by layer. For example, I'm going to transfer this element, this entity, to the new one system coordinate. Okay, to entity converted. Okay, some extension, and here is our entity that I'm going to copy and go to traverse and edit and paste to calculate, and we have in the new system 1, and in the other way around is the same. So you can check, it's very easy to work with MDT and the specific module like a surveying module. Okay, pues it's everything. I hope you enjoyed with my demonstration. I understand everything. David?
Yes, Antonio, thank you very much. I'm gonna make myself presenter again, and I will show you my screen. Okay. So to finish with this webinar, please remember that visiting our webpage, you can download the demo version of the modules that we have seen today in TcpMDT. You can find all the other version of the software TcpMDT, okay? And when you go down, you can find after checking some information here, you can download a dossier, request a quotation, or get your free trial version that will be worked during 30 days. Please remember, all our webinars have been also put in Applitop Academy, in Video Library, and you can find other softwares and review all the webinars we have done this last month of May and June. To finish, remember that if you need a quote, specific quote, as we get a lot of people asking for the price, we work exclusively through distributors. So in the locator, you can find all the distributor homologated to give you a personal quote for our software. But remember, this software is very low cost, and we are used to deal permanent licenses. So as you see here, you can add your country, and you will find several distributors that are able to make a quote. Thank you very much for your time. We appreciate to have all of you, and we hope to see you soon to other live demonstration or news. Thank you very much. Bye.